So we take that off. Again, that holds the switch, and I can actually pop that wire out of there, lay it to the side. And what we have left is our actual cutting mechanism. So this is made, all right, should pop right out. So that slides out. You'll notice that the cutter in here, it definitely is a type of tool steel that's been ground in a helical manner, all right? And helical cutters tend to cut more efficiently. They leave a cleaner finish on it. That's why they would do that. And my assumption is that they're assuming this will automatically be lubricated by the graphite. So it's actually still quite sharp. You wouldn't want to run your fingers across it too quickly. It's just a riveted, actually it's not. It has some type of clip in there, all right? But pretty basic design. You'll notice it's pretty sloppy, all right? I wonder if it wouldn't work better if it had a little tighter fit in there, but I digress, all right? There's also a little stopper in here, and what that's for is when you slide your pencil in, okay, and I won't even be able to get this in. That's what actually stops, all right, your pencil from going any further, so you don't continually grind the tip down, all right, and it's just spring-loaded so it can move a little bit, all right. The casting itself, this looks like a cast part. This is actually die cast, and it's indicative of the flashing right here. All right, so those little bits tell me that they had two halves of a die that went together, and then they would have injected this pot metal into it. This type of material, I believe, came out probably in the 1930s, I think. Don't quote me on that, but I think that's when it came out, and it was a wonder material because you can cast these precise parts or relatively precise parts very quickly and cheaply, and then cut some threads in it and send it down the road. It's relatively soft. You wouldn't use it for high strength things, but in appliances and whatnot, it's a great material. And in fact, the gear, all right here is made out of the same thing because they don't need to cut the teeth, which is expensive and time consuming. They can just cast those gear teeth in and done. So we've got our actual cutting mechanism. I would also say that this should be something that should be serviceable and replaceable, but it doesn't appear to be. All right, it actually looks like they might have spun the rivet on the end, but I'm not sure. So, anyway, we got that. Lay that aside. Okay. And what we're left with is this right here, and this appears to be, I do want to say it looks like nylon or Delrin, something like that. One of those types of plastics. Kind of looks like nylon to me. So this is a internal gear. So the teeth are injection molded in, and we can see all the injection sprues right there. Okay, all the injection points for the mold. They mold those teeth in. They're considered to be kind of self-lubricating. They wear well. Cheap part to make. Okay, we have two pins on here, so these are positive locks. So when you stick it into the housing, this doesn't spin. You don't want it to spin. And then, of course, we've got another set of locks we can place in there. All right, again, kind of setting that in place. Overall, I'd say the design of this isn't bad. It's pretty decent. It's simple. It's effective. It's just cheaply made, and that's what I don't like about it. I think that if we were going to improve this, I would say this is probably okay. But I think that we could make this to a tighter tolerance. We could make the cutter head to a tighter tolerance. I think the cutter itself is in good shape and last indefinitely. And what I would really like to see is bronze bushings. The other problem that we have with this one, if you look real closely, it already does have some wear. Something like this will have a tendency when it's sloppily made to wear on one side. And that's what it looks like is happening here. So the fit is, if I stick this in here, I can move it around and shake it pretty good. I don't like that fit. If you've ever done machine work, you would not be impressed with that. But it does account for thrust down inside of there. Okay, so that's going to wrap up our dissection of this pencil sharpener. And again, I didn't plug it in, but the other pencil sharpener that I took apart about a week ago, I did plug in and determined that it was most definitely this switch right here. All right, this limit switch or this micro switch right in here. They're just cheaply made. I was sort of hoping when I tore this one apart that it would be something else, and then I could take two of these pencil sharpeners and merge them into one good one and give it back to the teacher. But for what they pay for these, they're not that expensive. It's just, it's a disappointment. I think it is a simple design that works well, but could be executed a little bit nicer. you know, and have something. I don't honestly like the looks of it. I think it's kind of bulky and big, but that's just me. You know, doesn't necessarily affect its operation. So overall, good design, just some things that we could fix up. If I had machine tools at home, I'm not going to lie, I would be tempted to maybe try to machine something out of metal and make a tighter tolerance for this, just to play with it for the fun of it, not because we need a better pencil sharpener. But you know, overall, good design. Just you know, make it a little better, make it a little tighter tolerance. But the flip side to that is number one, planned obsolescence. So they know this is going to fail sooner or later, and guess what? They're going to sell more pencil sharpeners. You know, and again, the other thing is this is very, very quick manufacturing. They can knock these together quite quickly, just with the injection molding, the self-tapping screws, not using bronze bushings or anything. They're all, you know, very quick to make parts. You can make them by the thousands or the millions, in all honesty, and send them down the road. It does have a, let's just look over here. It does have a quality control sticker on it. So we know at some point it went through quality control. They probably plugged it in, spun it, and said, yes, it's good to go. And, you know, down the road it went. I hope you enjoyed this mechanical dissection. And I'm going to get some pictures of this broken down neatly. We'll clean it up later and put it back together and call it a day. So thanks for watching.